saying, no doubt, it's showing all signatures of an electrical comet. And then I've got people on the other side of that coin saying,
the interstellar object, 3IATLAS, has quickly become one of the most mysterious visitors ever recorded in our solar system, drawing intense attention from astronomers worldwide. Unlike any known comet, ATLAS displays a series of anomalies that challenge conventional models of celestial behavior. It accelerates in multiple directions, follows an orbit almost perfectly aligned with the ecliptic plane, contains remarkably little water, exhibits unusual chemical distributions, and radiates a brilliant blue light far hotter than expected for a comet. Its perihelion coincided with peak solar activity, a point at which massive outgassing and visible tails would normally appear, yet none have been observed, leaving scientists to rely on indirect measurements and orbital tracking to understand its dynamics. Adding to the intrigue, ATLAS's trajectory intersects the region associated with the historic 1977 WOW signal, sparking speculation that the object may be more than a natural interstellar body, potentially hinting at phenomena or intelligence beyond current understanding. Unprecedented observational challenges. The recent observations of the interstellar object 3IATLAS have presented a set of scientific puzzles unlike anything seen before in the study of comets or interstellar bodies. On November 5th, the Virtual Telescope Project released 2 new images that have confounded astronomers worldwide. These images depict ATLAS as a compact, bright point of light, entirely lacking the characteristic coma or tail typically seen in comets approaching the Sun. What makes this observation particularly striking is that ATLAS's appearance has remained nearly unchanged since the Hubble Space Telescope's images from July 2025, despite expectations that it should have lost at least 13% of its estimated 5 billion-ton mass due to intense solar radiation. This lack of visual evidence for such substantial mass loss is perplexing. If ATLAS were behaving like any natural comet, there would be an obvious cloud of gas and dust trailing the object, glowing brightly against the dark backdrop of space. Instead, ATLAS appears almost pristine, suggesting processes at work that defy conventional understanding. This situation highlights a deeper challenge. Astronomers are observing a period of maximum solar energy input without any direct indication of the expected material reactions. The absence of observable outgassing or debris clouds means scientists must rely on indirect measurements, orbital tracking, and careful modeling to infer what is happening on ATLAS's surface. The combination of high solar exposure, invisibility to direct observation, and unusual physical behavior sets the stage for what could be one of the most important studies of interstellar objects in modern astronomy, pushing researchers to question assumptions about cometary physics and interstellar matter. Strange accelerations. On October 29th, as ATLAS approached perihelion, its trajectory began to deviate from predictions in a way that surprised the scientific community. NASA's Jet Propulsion Laboratory reported a deviation of 4 arcseconds from the expected path, a small angular shift that translates to a movement of more than 80 kilometers in space over the course of a month. More remarkably, the object exhibited acceleration in 2 distinct directions, an outward push from the Sun at approximately 135 kilometers per month and a lateral shift of about 60 kilometers per month. This dual-direction acceleration cannot be explained by conventional gravitational interactions alone. Typically, comets accelerate primarily due to outgassing, as sublimating ice forms jets that act like natural thrusters. However, calculations indicate that to account for ATLAS's observed acceleration through outgassing, it would need to expel at least 5 billion tons of material, a volume that would create a bright, detectable cloud of gas and dust. Yet, no such cloud has been observed. The discrepancy between the expected and observed phenomena has prompted scientists to explore a range of hypotheses, from unusual natural processes to unknown mechanisms of propulsion. This extraordinary acceleration, coupled with the absence of a visible coma, positions Atlas as one of the most enigmatic bodies ever studied in the solar system, prompting a reassessment of our understanding of interstellar physics. Orbital peculiarities. Atlas's orbit adds yet another layer to its mystery. The object travels on a path tilted only 5 degrees relative to the ecliptic plane, the plane in which all the planets orbit the Sun. For an interstellar object entering the solar system, this near-perfect alignment is statistically extraordinary. Most interstellar objects would approach from random directions, intersecting the planetary plane only by chance, making such precise alignment highly improbable. Beyond the statistical anomaly, this orbit is mechanically advantageous, allowing Atlas to pass near multiple planets while minimizing energy expenditure. Such a trajectory could be interpreted as optimized for efficient movement through the solar system, a feature that has led some scientists to speculate about the possibility of intentional navigation, though no direct evidence currently supports artificial intervention. Regardless of its origin, the orbit provides a unique opportunity to study how an interstellar object interacts with planetary gravitational fields, potentially offering insight into dynamics that are otherwise impossible to observe in naturally occurring objects from outside the solar system. Physical and chemical anomalies. Spectroscopic studies of Atlas have revealed a series of chemical and physical peculiarities that further distinguish it from known comets. Data indicate an unusually high emission of nickel concentrated within 600 kilometers of the nucleus, while cyanide extends over a slightly larger radius. In typical cometary physics, the sublimation of different compounds occurs in roughly proportional patterns according to volatility and solar heating. Yet Atlas exhibits a distinct separation in chemical distribution. This suggests complex internal processes or structural heterogeneity. Moreover, its water content is extraordinarily low, approximately 4% by mass, far below the expected levels for comets, which are typically dominated by water ice. Polarization studies reveal a pattern not observed in any other known comet, suggesting that Atlas's surface may have unique reflective properties, potentially indicative of refractory materials or complex composite structures. The combination of unusual chemical distribution, minimal water, and unique polarization challenges existing models of cometary formation and behavior, raising questions about the diversity of interstellar objects and the environments in which they form. Anti-gravity behavior. One of the most startling aspects of Atlas is its apparent anti-gravitational behavior. Unlike conventional comets, which develop tails pointing away from the Sun due to solar radiation pressure, Atlas exhibits material ejection in the opposite direction, toward the Sun itself. This behavior contradicts basic physical expectations and indicates either a previously unobserved natural phenomenon or the influence of an unknown external factor. The jet directed sunward, coupled with the unusual acceleration, implies that forces other than gravity and conventional outgassing are acting upon the object. The magnitude of the acceleration and the absence of a corresponding gas cloud make the natural explanation increasingly difficult to maintain, further highlighting Atlas's uniqueness within the known population of interstellar objects. Size and mass. Atlas is also remarkable for its sheer size and mass. Estimated at approximately 33 billion tons and nearly 6 kilometers in diameter, it is orders of magnitude larger than either Oumuamua or Borisov, the first two confirmed interstellar visitors. Despite this enormous mass, Atlas moves faster than smaller comets, challenging expectations based on standard gravitational dynamics. Larger celestial bodies typically exhibit slower motion due to their interactions with stellar gravity, yet Atlas appears to defy this trend. The combination of immense mass and anomalous acceleration reinforces the notion that Atlas is not a conventional object and suggests the potential presence of internal mechanisms influencing its motion or composition. Composition and surface features. Detailed analysis of Atlas's composition has revealed characteristics that resemble high-temperature alloys more than naturally occurring cosmic materials. The ratio of nickel to iron, unusual even for interstellar objects, mirrors that found in industrially processed metals. The low water content and absence of volatile compounds reinforce the hypothesis that Atlas's surface may be coated in a refractory layer, potentially ceramic or composite in nature. If confirmed, this would imply a level of structural stability and resilience far beyond natural cometary bodies, making Atlas not only chemically but physically unique. Spectroscopic patterns also indicate a surface geometry capable of reflecting light in specific directions, further distinguishing it from irregular, diffuse comet surfaces and raising the possibility of purposeful structural design. Cosmic coincidences and hypotheses. Intriguingly, Atlas's path appears to intersect the same region of space associated with the famous 1977 WOW signal, one of the most debated observations in the history of the search for extraterrestrial intelligence. While the probability of such a coincidence is extremely low, the alignment has fueled speculation regarding potential links between the object and previously recorded unexplained cosmic phenomena. Combined with its other anomalies, unusual orbit, dual-direction acceleration, anti-gravitational jets, extreme mass, unique chemical composition, and reflective surface patterns, Atlas represents a profound opportunity to expand our understanding of interstellar matter. Whether the explanation lies in unusual natural processes, undiscovered physical phenomena, or highly speculative artificial factors, the object challenges astronomers to explore beyond conventional models. Observations over the coming months, including close approaches to Earth and Jupiter, will be critical in determining how Atlas behaves under solar influence and whether its unique properties persist or evolve, offering a chance to unravel one of the most compelling mysteries in modern astronomy. Unusual thermal properties. Perhaps the most striking anomaly of 3IATLAS is its apparent temperature and coloration. Observations indicate that Atlas is emitting a brilliant blue light, suggesting energy levels exceeding 5,800 Kelvin, the surface temperature of the Sun. For a non-stellar object, this is extraordinary and cannot be explained by conventional cometary physics. Natural comets, even when exposed to intense solar radiation at perihelion, cannot generate this level of energy. The blue hue indicates that the object is radiating far more heat than expected for its size and distance from the Sun, challenging astronomers to reconsider assumptions about energy generation in small celestial bodies. This thermal anomaly is particularly notable because it coincides spatially with the constellation Sagittarius, a region historically associated with unusual astronomical phenomena. Connection to the WOW signal. Another intriguing aspect of Atlas is its trajectory. The object's path through the solar system intersects the same region of space where the famous 1977 WOW signal was recorded. This coincidence has led some researchers in the search for extraterrestrial intelligence, SETI, field to speculate that Atlas could be linked to the origin of the signal. Some hypotheses suggest it might act as an intermediate object, possibly transmitting signals in periodic cycles across decades, functioning as a kind of cosmic relay station. While these ideas are highly speculative, the alignment of both Atlas's trajectory and the location of a historically significant anomalous signal invites deeper investigation into whether the object is purely natural or has an engineered component. Potential evidence of extraterrestrial technology. If Atlas's numerous anomalies, including its unusual orbit, dual-direction acceleration, minimal water content, anti-gravity jet behavior, metallic composition, and extreme thermal emission, are confirmed, it may no longer be classified simply as a comet. Some scientists propose that Atlas could represent the first experimental evidence of interstellar technology, perhaps an autonomous probe launched by an ancient civilization millions of years ago to monitor the solar system. Such a probe might be designed to gather and transmit data, with its observed properties reflecting advanced engineering rather than natural processes. While this is a highly speculative theory, the sheer number of deviations from expected comet behavior keeps the discussion open. The question of whether Atlas is a natural object or an engineered artifact has become central to modern astrophysics and SETI research. Upcoming observations. The coming weeks are crucial for resolving these mysteries. Atlas will make its closest approach to Earth on December 19th, providing astronomers and observatories a unique opportunity to directly measure its properties. If Atlas truly exhibits the acceleration observed, the required loss of mass to account for it would produce a massive gas cloud, which should be detectable by ground-based and space telescopes. The absence of such a cloud would suggest that the object's acceleration is being driven by unknown mechanisms, potentially of technological origin. Each new observation will add critical data to the debate, gradually clarifying whether Atlas is a highly unusual comet or the first tangible example of interstellar technology interacting with our solar system. These measurements may forever change our understanding of what interstellar objects can be and challenge assumptions about the limits of natural celestial behavior. The approaching close encounter. On December 19th, 3IATLAS will make its closest approach to Earth, and the astronomical world is preparing for an unprecedented observational event. Hundreds of telescopes, both ground-based and orbital, will focus on the object in hopes of resolving long-standing mysteries about its nature. For months, scientists have debated whether Atlas is a highly unusual comet or something far more extraordinary. The approaching close encounter provides the first opportunity to test critical hypotheses about its behavior. Researchers are particularly interested in the acceleration Atlas exhibited during perihelion. If this acceleration was caused by outgassing, the comet would have lost around 5 billion tons of material, producing a gas cloud that should be detectable by our most sensitive instruments. Observing or failing to observe this cloud will be pivotal in confirming or refuting the comet hypothesis. The acceleration enigma. The anomaly in Atlas's motion has baffled astronomers since its perihelion in late October. Unlike typical comets, which follow predictable gravitational trajectories with slight deviations caused by outgassing, Atlas appears to accelerate in ways that defy conventional physics. Its movement is not only faster than expected, but occurs in multiple directions simultaneously, suggesting forces at work beyond simple solar radiation or gravity. If natural outgassing were responsible, the sheer volume of expelled gas would be enormous, creating a visually detectable cloud around the object. The absence of such a phenomenon would indicate that a different mechanism, potentially one of technological origin, might be propelling Atlas. The implications of this are profound. An interstellar object behaving in ways inconsistent with natural processes challenges our understanding of celestial mechanics and the potential for advanced technologies beyond Earth. Observational stakes. The upcoming observational window is not merely academic. It carries the potential to redefine humanity's place in the cosmos. Telescopes worldwide will record Atlas's trajectory, brightness, spectral properties, and any material ejected during its passage. Scientists hope to capture precise measurements of velocity changes, chemical composition, and any anomalies in emitted radiation. The stakes are high because the data could either validate decades of cometary physics or reveal phenomena that demand entirely new theoretical frameworks. Researchers are particularly interested in subtle deviations from predicted paths, which might hint at mechanisms that operate outside known physical laws. Each observation has the potential to shift our understanding of interstellar objects, revealing either natural complexity or evidence of intelligence operating beyond our current reach. The possibility of interstellar technology. Among the more daring hypotheses is the suggestion that Atlas might not be a comet at all, but an autonomous probe or device originating from another intelligence. Its unusual properties, accelerations inconsistent with outgassing, high-speed traversal, extreme blue coloration, and minimal water content, raise questions that conventional comet models struggle to answer. If Atlas is indeed an artificial object, its trajectory, orientation, and movement could reflect deliberate design. This hypothesis does not suggest science fiction in the casual sense. It reflects the rigor of evaluating empirical anomalies without bias. Considering the possibility that Atlas could be an interstellar technological artifact encourages scientists to explore unconventional models while remaining grounded in observable data. Timing and cosmic coincidences. Atlas's timing in the solar system has added to the intrigue. Its perihelion coincided with periods of high solar activity, intensifying interactions between the object and the sun's radiation. Its trajectory also intersects the constellation Sagittarius, the same region where the famous WOW signal was detected in 1977. These coincidences have fueled speculation that Atlas could be part of a larger interstellar observational or signaling system. While some researchers caution against reading intent into celestial coincidences, the repeated alignment of unusual events challenges the notion that all patterns are purely coincidental. Such considerations emphasize the importance of rigorous, systematic observation during the December 19th approach. The Mirror Galaxy Hypothesis. In certain scientific and online communities, a provocative theory has emerged, sometimes called the Mirror Galaxy effect. This hypothesis suggests that advanced civilizations might deploy observational devices to monitor emerging civilizations, activating them once a species reaches a certain technological threshold. Under this scenario, Atlas could serve as a sentinel, scanning the solar system for indicators of advanced technological development. If this interpretation has any validity, its close passage near Earth may represent a pre-programmed observational check rather than a random interstellar crossing. While highly speculative, such a concept underscores the importance of maintaining an open but critical perspective when examining objects that defy conventional classification. Anticipating discovery. As December 19th approaches, the anticipation in the astronomical community is palpable. Observers will monitor Atlas for signs of mass loss, unusual accelerations, or emission of energy in unexpected bands. Any deviation from the expected physical behavior of a comet could dramatically shift scientific consensus. If no outgassing or corresponding gas cloud is observed, the idea of an artificial mechanism powering Atlas will gain serious credibility. Beyond scientific curiosity, these observations may have profound philosophical and cultural implications, challenging humanity to reconsider its understanding of life, intelligence, and our place in the cosmos. The data collected in this short observational window could define astronomical research for years to come. Broader implications and reflection. Whether Atlas ultimately proves to be a natural comet or evidence of interstellar technology, Its passage represents a turning point in the study of our solar system and the universe at large. The anomalies observed thus far, extreme acceleration, unusual coloration, precise orbital alignment, minimal water content, and potential links to historical cosmic signals, invite a reevaluation of our assumptions about celestial objects. December 19th will provide clarity, but the story of Atlas also reminds us that science progresses not only through confirmation, but through confrontation with the unknown. Atlas challenges humanity to observe without bias, theorize without limitation, and remain open to possibilities far beyond the conventional paradigms of astronomy. The countdown is not just for an observational event, but for a potential moment of profound cosmic realization, where humanity may glimpse either the full complexity of natural interstellar objects, or, for the first time, evidence of intelligence reaching across the stars.